Hello, this is my Physics 2211 Lab 4 lab report on oscillations. In this lab, we focused on using Tracker to extract the position data for the mass in the given video. Then we saved this data and put it into a computer code to return an expected graph of the energies and positions of the mass. After we had our expected results, we needed to compare the predicted motion and the observed motion of the mass, and plot the energy changes that we computed in the model. Some of the fundamentals we used in this lab were the velocity update formula, the position update formula, gravitational energy, spring energy, kinetic energy, total energy, gravitational force, and spring force. I included all of these formulas on this slide. These are the graphs returned from the computer program. The left two show the positions, and from those graphs we can see that the positions predicted are pretty accurate when comparing to the actual experimental data. The graph below shows the change in energy graph. This graph supports the idea that the energy in our system is constant. Our energy level stayed close to zero the entire experiment, even though individual energies changed. Here are the initial conditions. I included position, velocity, mass, spring constant, oscillation period, the L vector, L naught, system, and surroundings. For this experiment, I was given a video to analyze in Tracker. I used a calibration stick of 0.7 meters to measure the length of the spring and set my origin at the point of connection. Then I tracked the mass's motion throughout the oscillations. After the data collection, I recorded the initial position, initial and final times, and calculated the initial velocity using the formula at the bottom. Then, I exported my data into a CSV file and began coding my computer program. In these lines of code, I initialized my variables such as mass, position, velocity, time, delta t, the initial energies, and initial spring characteristics. Then, I entered the calculation loop, which started by defining the initial energies as the energies calculated from the position before, unless it was the first loop. Then it used the energies calculated in the initial section from the slide before. Then it calculated the gravitational force and the spring force and added those together to equal the total force. Then, using Newton's second law and the position update formula, it calculated the new position and new velocity of the mass. Next, it had to calculate a new L value, S value, and L hat value for the new energy calculations. Finally, the loop calculated the new energies using the same formulas from before and went through the loop again. We can see in the top two graphs to the right, the results are pretty similar and they follow the same pattern. The experimental data, shown in red, does not go as far to the right, left, top, or bottom as we expected using the computer program. In the bottom graph, we can observe the conservation of energy. The energy model shows the energy level, which, while the separate energies are changing values, is staying very close to a value of 0. This shows how the change in energies is balanced throughout the experiment. My main source of error is probably from inaccurate tracking, human error, since I cannot click the exact center of mass every single time. It is very possible that I may click a little bit to the side or a little bit too low, and this will mess up the calculations. Another source of error could be from rounding. If my numbers were rounded too soon, then it probably altered my results. For the first question, my answer would be yes. For my model system, the energy principle is satisfied. The energy principle shows that the total energy for a system is constant and it does not drastically change. My graph shows a transfer between kinetic, spring, and gravitational energy, which all end up equaling to about 0 at all points during the experiment. This supports the energy principle is satisfied. For the second question, my x position estimate was 1.6143 seconds, and my y position estimate was 1.456 seconds. My period of oscillation estimates for x and y positions were not identical, but were very similar. I expected the values to be identical, and I believe that the reason that they are not is because of my inconsistency in tracking. Realistically, in a perfect world, these two estimates should be identical, but because of my error, they are not. Thank you.